Hey Professor, I'm going to be doing my project on a charger, a power supply, and talk about how it goes from AC current to DC current, and the processes that are involved with that. Yeah, I'm going to use my calculator charger as an example. So, this diagram from the textbook shows us the basic process of a basic DC power supply. We have our AC input that comes from the wall socket, the transformer, a rectifier, filter, and a voltage regulator, and then finally our V output that goes into our phone or any other device. So first off, our supply of current comes directly from our wall sockets. It is alternating current and ranges around 120 volts in the US. And yeah, in order to be able to charge our phones and any other devices, we want to be able to convert that alternating current into direct current. And we're going to talk about how that process goes. So this is a transformer, also known as a voltage transformer, primarily for the reason that it can manipulate the flow of voltage going within a circuit. And what comprises a transformer are the two windings that are there. The first one on the left being the primary, second one being secondary. And each winding has a different amount of coils. If the primary has less coils than the secondary, then it would be a step up transformer, which just means that a voltage going in would be higher going out. And if we want to be able to step down, we would have more volts on the primary and then less volts on the secondary. And the main reason we're able to do this to begin with is because it's an alternating current, which has magnetic flux, which induces voltage. So for our system, we would want to be able to have a step down transformer. So since we have alternating current, we're going to have both a positive cycle and a negative cycle. And that's when the rectifier comes in, which uses diodes to make the current flow either always positive or always negative. So it'll kind of look like the graph you see there. It'll be like the absolute value function of the voltage. And in particular, we are going to be using a bridge rectifier for what we're about to do, which compromises of 4 diodes. And what it basically does is it within like the positive half, 2 of the diodes conduct and then the other 2 are off, and then the reverse happens for the second half of the cycle. So we can see that the amplitude of the voltage varies by a lot, and we want it to be as close to the DC level that we want. And we're going to accomplish this through a smooth filter. And how that's done is we're going to put a capacitor in parallel with the loading resistor. And what's going on is that the current from the rectifier is high, so it'll charge this capacitor. And when the output voltage gets lower than the voltage of the capacitor discharges, keeping the current high. So in a sense, it smooths it out, like it balances it out. So finally, our voltage regulator. And what this does is basically just linearizes our voltage output, since it's still a little bit of an arc when it comes in beforehand. So yeah, now we're going to talk about the process of actually building the circuit. So yeah, this is going to be our final product. This is going to be the multisim for our charger. So I'm not able to have all the components since I'm using this program, so the voltage output is going to be limited to 1 volt. But we can see all the processes going on here. We can see the AC input, the transformer, the rectifier, the smoothing filter, and the voltage regulator. So yeah, this is a graph of what's going on. The light blue line is what our AC input, and we can see it's very large. And then the pink line is the after the transformer, and also with the what's it called? the rectifier as well, since we see it's only positive. And then the blue line is after the filter, and then the green line is our final voltage output. So yeah, that's the end of my project. I hope you have an amazing and awesome summer and that you stay safe.